Hi, welcome back everyone to the last video on active sources. And I'm taking this video because this kind of video has not been done in any of the YouTube channels, and this would be very useful for you when you deal with the electrical circuits, when you deal with different kinds of sources actually. So all of you are able to see the picture of a battery. So this is a very common picture in your mobile stating like it has 14% charge. So what I want to tell you is many of them, they doesn't know like this pointing surface means positive polarity and this base stands for negative polarity. To bring you more clarity, I have this picture of an AA battery, which everyone uses in their remotes or toys or many kinds of things actually, daily household devices. So this pointing surface, everyone you can see, this stands for positive and the base stands for negative. I will just show some pictures because why I'm telling you very clearly about the pointing surface to be positive and the negative one to be a base, because you know in previous days they used to have a torch lights, they used to keep batteries, so the negative touches the positive, so just like this picture. So all of you can see this picture. In this picture, this is an AA battery which gives 1.5 volts, or because of, it's giving 1.12 volts is indicated here. You can see this negative of this battery is connected to positive of the another battery here. And the negative is connected to positive of the another battery here. And the positive of the first one and the negative of the this one, negative of the last one are being connected to a voltmeter which measures 3.6 volts. How did I get 3.6? 1.2 plus 1.2 plus 1.2 gives me 3.6 volts. That is how it is going to operate. So this is a physical picture. If I write it in the form of a circuit, all of you can see the first one is a positive and the longer line is positive and the shorter one is negative. The negative is connected to longer one, which is positive. Again, the negative of that is connected to a longer one, which is positive. And from the negative of this and from the positive of the first one, it is connected to the voltmeter. So you can see here, the negative is connected to positive of the two batteries. The negative is connected to positive of the two batteries, which means if the opposite polarities meet, then there is an addition actually. So because this 1.2 plus 1.2 plus 1.2 becomes 3.6. So when opposite polarities, which means the negative of this B1 is connected to positive of the battery 2 and the negative of the B2 is connected to positive of B3. And if I measure the voltage from the positive of B1 and negative of B3, I get the voltage of 3.6 volts. So if I connect the AA batteries in series, this is a series connection. So it gives 3.6 volts. I want to show you, as I was mentioning about the torchlight here, all of you can see this is 1.5 volts battery with 2000 mAh, and this is also a battery with 1.5 volts with 2000 mAh. You can see the positive terminal is this and negative is this. It's indicated here. The negative of the one battery is connected to positive of the battery. So which means we have to add. So these two batteries, they add up and the voltage across these terminals is 3 volts. As they are connected in series, what happens? Current remains same. So 1.5 and 1.5 becomes 3. So 3 volts will be lying across these two terminals. So that's what we have to understand from the series connection. Another example I want to show you to bring you more clarity. So you can see negative of battery 1 is connected to positive of battery 2. Negative of battery 2 is connected to positive of battery 3. Negative of battery 3 is connected to positive of battery 4. And from the first one and the last one, I find out what is the voltage. You can see opposite polarities meeting. You can see opposite polarities meeting. You can see opposite polarities meeting. So they add completely 1.5 plus 1.5 plus 1.5 plus 1.5. 6 volts is the voltage across the first and the last battery terminal. So they are being indicated in the form of circuit here. Battery 1, 1.5 volts, battery 2, 1.5 volts, battery 3, 1.5 volts, and battery 4, 1.5 volts. Add them, negative meets the positive, negative meets the positive, negative meets the positive. So what is the final voltage? It is the 6 volts. So that is how parallel connections comes into the picture. Now people would be having a doubt. Yeah, parallel connection, series connection is fine. How does a parallel connection is going to have? So you can see here the 4 AA batteries are connected in parallel. As I have discussed in my previous videos, in parallel voltage is going to be same. So all over from the positive to the negative, the voltage is going to be same. But current, what happens to current? This one contributes 1000. This one also contributes 1000. The next one contributes 1000, and the next one contributes 1000. I have indicated in the picture. This one contributes 1000. When it goes and adds with another 1000, it becomes 2000. 2000 will add with the next one, it becomes 3000. 3000 will add with the next one and become 4000 milliamperes. And as in parallel, voltage is same. So you have 1.2 volts across these two terminals. The output terminals are positive and negative terminals. So with that, what are the things which we have discussed? We have discussed about series connection and parallel connections of the voltage sources. In series connections, when opposite polarities meet, we have addition of the voltage. When same polarities meet, we have a subtraction. When positive meets the positive or negative meets the negative, we have a subtraction. And this is a parallel connection where voltage is going to remain same, but the current keeps on varying. So with that, I complete the active elements part of the basic electrical engineering. Thank you very much, all of you. So please like, subscribe, and comment for all these videos which are in this channel. Thank you.